Hello guys, so in today's video we are going to solve Goa Board's SSC question paper of the year October 2012, okay, on the topic of probability. So now question 1A says if two coins are tossed together, then the probability of getting at least one tail is dash, and here we have the options, okay. So now how to simplify this? So there are two coins tossed together, so that is why I have taken two coins, so coin 1 and coin 2, okay. So in the first case, if we toss both the coins, we might get head and head, okay. In second attempt, we might find a pair something like head and tail. In the third attempt, we get some kind of pair like tail and head, okay. And in the last attempt, that is, we'll get tail and tail, okay. So now these all four are the all possible outcomes, okay. When you toss two coins simultaneously, आपको इससे ज़्यादा और combinations नहीं मिलेगा, okay. So these are the only four combinations which you are going to get if you toss two coins simultaneously, okay. So now what we have to do? We have to find the probability of getting at least one tail. That means what? We have to take only those combinations where at least one tail is present, okay. It can be more than one, but at least that is minimum. At least means minimum one tail. So in the first combination, do we have any tail over here? No. In the second combination, do we have any tail? Yes, we have one tail, okay. So our requirement is at least one tail, so this we can take. So I have written it down over here. So I'm just trying to find out favorable outcomes, okay. So that is favorable outcome of at least one tail. So this is valid one, so I have written it down over here. Now here in the third combination, can we see? Yes, so at least one tail is present here, okay. So that is why I have written here tail and head, okay. So but in the last combination we can see tail and tail, okay. So here we have two tails, okay, but our requirement is minimum one, okay. It can be more than one also, it can be 2, 3, okay. So here we have two, so we'll have to take this also. So tail and tail, okay. So now our all favorable outcomes are how many? 1, 2, 3, okay. And how many how many we have total combinations? So altogether we have altogether 4 combinations, okay. So what we have to find? Probability of at least one tail, okay. So that is favorable outcomes upon total outcomes. So total outcomes we have 4. 1, 2, 3, 4. 1, 2, 3, 4. So this is total outcomes. And favorable outcomes, that is at least one head. So here we have, so how many are there? 1, 2, 3. So 3. So 3 upon 4, okay. So is this option available? If we can check here we have this option available, okay. So this is the perfect answer for this. Now we'll take the second part of this question, okay, which is asked for 2 marks. So okay, basically this is known as word problem, okay. So a die is thrown once, okay. Find probability of getting. So the first question is a number less than 5, okay. So first of all, if we roll a dice, what we will get? What are the possible outcomes? In the first attempt we can get 1, we can get 2, we can get 3, 4, 5, 6, okay. We cannot get 7 because on a dice we don't have number 7. We have only 6 numbers, okay. A dice has only 6 phases, right? On each phase we can write only one number, so that is altogether 6 phases, 6 numbers, okay. So now these are all possible outcomes. So now we have to find the probability for a number less than 5, okay. So now that is favorable outcomes. So now which are the numbers that are less than 5? So less than 5 is here, these numbers, right? So how many are there? 1, 2, 3, 4. So there are 4 numbers, right, which are less than 5, okay. So all the 4 numbers are, we'll have to put them in this category. So that is favorable outcomes are 1, 2, 3, 4, okay. So which are less than 5, okay. And what is the question? A number less than 5. So probability of number less than 5 is equals to 4 numbers we have, right? 1, 2, 3, 4. So that is 4 upon total number. What is the all possible outcomes? So possible outcomes are 6, right? So that is by 6, okay. So if when we cancel this, we'll get 2 upon 3, okay. So now we'll look at the second question, that is a non-prime number. So we have to find the probability of a non-prime number. So if we roll a dice, what we'll get? We'll get all the possible outcomes as 1, 2, 3, 4, 5, 6. Okay. Now out of these 6 numbers, we have to find only, we have to find non-prime numbers. Non-prime numbers means the numbers which are not prime. Okay. So what I have done over here, I have first found prime numbers. Okay. So what basically prime numbers are? If you don't know what basically prime numbers are, I have made one table for you. So this is a table what we have. There are different types of numbers. So the first number is natural numbers. Okay. So natural number, how to remember? Natural number starts from 1. Okay. Can you see this? 1 and 1. I have highlighted this. So this is the best way to remember. Natural number starts from 1. Okay. Second type of number we have whole numbers. Whole numbers starts from 0. Okay. Can you see this circle? O I have highlighted, and here I have highlighted 0. Okay. So this is the second way to remember what whole numbers are. Okay. So basically natural number starts from 1. Whole numbers starts from 0 and goes till all the positive numbers. Okay. Till infinity. Now the third type of number that we have are integers. So integers are natural numbers plus whole numbers and plus negative numbers also. Okay. So that's the only difference. Okay. So if you take natural numbers, you will automatically get if you take integers, you automatically get natural numbers as well as whole numbers. And the fourth type of number we have rational numbers. Okay. So rational numbers are which can be written in ratios. Okay. And after dividing them, we get the value in decimals. Okay. That is like 0.2. This is a rational number. Okay. It can be in negative also. Okay. So then the second kind of example is here 5/6. Okay. So here can be, these rational numbers can be expressed in P upon Q, and where Q is not equals to 0, obviously we cannot have 0 in the denominator at any point of time in mathematics. Okay. And the second thing is every point is a rational number. Every integer is a rational number. Okay. So every integer is a rational number. Okay. Now there's another pair which are called as even numbers and odd numbers. Okay. So all the numbers can either be even number or it can be odd number. Okay. So even numbers basically are multiples of 2. Okay. So here I have written multiples of 2. 2, 4, 6, 8. Okay. Basically we have to write table of 2. Okay. So those all numbers are even numbers. And remember, even 0 is also an even number. Okay. And similarly we have odd numbers. So odd numbers are non-divisible by 2. Okay. So once we have written even numbers, so all those remaining numbers which are left out, so those numbers are called as odd numbers. Okay. So numbers which do not appears in 2's table. Okay. So they are called as odd numbers. Okay. Now the next pair is prime numbers and composite numbers. Okay. They are opposite of each other. Okay. So basically we were looking for this, right? Prime numbers. So prime numbers are numbers which only have 2 factors. Okay. For example, 2, how many factors it is having? That is 1 into 2 we can get. Okay. 2 into 1. That means the number should appear in one's table, and that same number should appear in its own table. Okay. And nowhere else it should appear. So guys, now take the second example, that is 3. So 3 appears in its own table, and it also appears in one's table. Okay. Now what about 4? If we take 4, yes, obviously 4 appears in its own table. Okay. 4 also appears in one's table. Basically all the numbers appears in one's table. Okay. But 4 also appears in 2's table. So now here it is having 3 factors, right? So 1, 2, 3 factors. So the number which are having more than 2 factors are called as composite numbers. That's it. Okay. A number can be either prime number. If it is not prime, then it is a composite number. Okay. So composite number definition we have the number which is having more than 2 factors are called as composite numbers. You have written, see, 4, I have already shown you, it is having 3 factors, so it is a composite number. 6, so 6 appears in its own table, 6 appears in one's table, and we get 2 into 3 also as 6. So it is having more than 3 factors, right? So it is a composite number. Now there is something very important which you have to remember. Okay, so number 1 is neither prime nor composite. Okay, so 1 cannot be prime number and it cannot be composite because 1 is having only one factor. Okay, so I hope guys you have understood the definition for prime numbers. Okay, so among this all the possible outcomes, so I have written it down 1 2 3 4 5 6. So out of this we have how many prime numbers? 2 is a prime number, 3 is a prime number, and 5 is a prime number. Okay, so what we have to find? We have to find non-prime numbers. Okay, so these are prime numbers, so whatever the numbers which are left out, I have circled them, and those numbers are non-prime numbers. Okay, so 1 is a non-prime, 4 is a non-prime, and 6 is a non-prime. So we have 3 numbers which are non-prime. Okay, so we have to find probability of non-prime numbers, which is equals to all the possible outcomes. How many outcomes we have? We have 6 outcomes. So 1 2 3 4 5 6. If we roll a die, we can get any of these 6 numbers. Okay, so that is why 6 outcomes. Okay, and on top we should write favorable outcomes. So what is the favorable outcome? We should find a non-prime numbers. So non-prime numbers are 3. Okay, so 1 4 and 6. So we have 3 numbers, so 3 upon 6, which is equals to 1 upon 2 after cancellation. So guys, that's the end of the question. Okay, if you have still left with some doubts or questions, you can let me know in my comment section, so then I'll try to provide solution for those questions. Okay, so till then, stay tuned and keep learning. I'll see you in my next video.